As an introduction, we prepared this table with the disadvantages and advantages of each purification method. First, a 0.8% agarose gel was prepared. Then, from a 20 microliter sample of DNA, 10 microliters were used in a 1 to 100 dilutions to be quantified on the spectrophotometer. The remaining DNA sample was put into our gel and it was run at 110 volts. Then, using a transluminator and adequate protection gear, the band of interest was cut. This band was put into a previously weighted microtube, and after calculations for every 400 grams of gel, 1.2 milliliters of LE buffer were added. Then the microtube was introduced into a thermostatic bath at 15 degrees Celsius for 15 minutes and mixed by immersion every 3 minutes. After that, the sample was put into an extraction column and centrifugated at 12 kgs for 1 minute, and supernatant was discarded. Then 500 microliters of wash buffer were added, and the sample was centrifugated under the same conditions and supernatant was discarded. Then again centrifugation process was repeated for 3 minutes and the sample was changed into a recovery microtube. Then 50 microliters of ES buffer were added and the sample was incubated at room temperature for 1 minute, then centrifugated under the same conditions. The eluted sample was recovered and kept at minus 20 degrees Celsius for further usage. In the gel, we can only see clearly the bands belonging to the teams 2 and 4. The line that is observed in lane 4 is due to a puncture in the gel while loading it. In lane 9, we can observe 2 bands, which means that our sample needs further purification. About the marker, we can say that the quantity loaded was too much and therefore the band seemed distorted. Also in lane 9, a clearer band is present all the way from the top. This means DNA was degraded.
In purification, we use the Invitrogen PureLink kit. It's a very easy procedure, but also have their critical points. The first one is that you need to cut the DNA band with the less amount as possible of agarose in order to don't saturate the silica column. Other critical point is that briefly you dissolve the agarose with the DNA, you need to know the weight of the agarose in order to have a reference and can count the obtained amount of DNA. Once you have the liquid, you need to be very careful with the amount you put in the column. If it's needed, you have to repeat the centrifugation and discard of the residues as many times as needed. The first wash with buffer L3 is very important because it has some agents that modify the silica column charge. Purification is a basic procedure and a critical one in order to have possible results with the next procedure. There are many ways to purificate the DNA. Depending on what you have in your laboratory, you can determine the better way to do it. All have their pros and cons, but you have to adapt and know the procedure to have the better results.
The bands are absurd because when we cut, we could have taken both bands because they were very close together. So the purification process was not effective. But when we repeated the process, we obtained just one band after the purification process. An important thing that I've learned is that when we centrifugate, we have to discard the supernatant, and that could be done roughly without damaging our pellet, but you still have to be careful so you do not disintegrate those cells that are already compelled. In conclusion, this purification method is very effective when done correctly, and you can obtain pure products of the electrophoresis or PCR that you've done.
The use of the spectrophotometer is essential to know the purify of the sample, and similarly, the amount that I use in the electrophoresis. Performing electrophoresis lets you know the purify according to what is obtained in the lane may be degraded because the genetic material. There are several critical steps for the correct purification of VNI from agarose gel. The time of exposure of VNI to UV light used to identify the PCR product in a transilluminator because it's Alone exposure time could nick the PCR supply. Another critical step is trimming of the gel after visualizing the DNA in a transilluminator. The gel slide should be trimmed as much as possible, and the excess gel that does not contain DNA should be removed for a higher purification yield.
In this laboratory practice, we did purification and we did use our two samples of proteins, H1 and H2, because in our previous electrophoresis in the other practices, we did get results. And in the electrophoresis we made to cut our band, we didn't get what we expected because we were expecting two bands and we only see one. This can be because of the concentration of the gel because it wasn't right for our proteins or the time wasn't right. So so that's why we didn't get our results, but it didn't matter because the purpose of this purification was only to get a band. So we cut that white band and we used it to purify. And in the electrophoresis made afterwards, the results were great because we did obtain that band that we cut with the same length. So this means that the purification was well made.